This lesson is on solving a two-step problem involving acceleration and distance. Again, we're going to always use the same steps. Make a picture, a dot diagram, list your knowns and unknowns, the appropriate formula, plug in your information, solve with order of operation, and the appropriate units. Today's problem is a sailboat is moving at 5.1 meters per second and a strong wind increases its speed to 9.5 meters per second to the east in 4.3 seconds. Determine its acceleration and how far it traveled during that time. So here's our sailboat, and a strong wind increases it from 5.1 meters per second to 9.5 meters per second. It's going towards the east, so we know it's in a positive direction, and this happened in 4.3 seconds. Again, our dot diagram is going to illustrate that we increased its acceleration and that it went in an east positive direction. What do we know? We know that our initial velocity was 5.1 meters per second, that our final velocity was 9.5 meters per second, that our time is 4.3 seconds. What we're looking for is our acceleration, which will be in meters per second squared, and our displacement, or our distance. How far did it travel during that time? How many meters did it go? So we're going to use our acceleration formula first. Acceleration equals final velocity minus initial velocity over time. Plugging in our values, we have 9.5 minus 5.1 divided by 4.3. You always must subtract the numerator first. When we subtract that, that is going to give us 4.4. We divide that by 4.3, and our acceleration is 1.02 meters per second squared. We need the acceleration information in order to find out how far it traveled. Our next formula is our displacement, or our distance, equals the initial velocity times time plus 1/2 of the acceleration times time squared. Let's plug in our values. Our initial velocity, we have 5.1 times our time, which was 4.3. To that, we're going to add 1/2 of our acceleration, which was 1.02, times our time squared, which is 4.3. Now, orders of operation tell us that we must square first on this side. So we can multiply this. 5.1 times 4.3 is 21.93. To that, we're going to add our time that is squared, which is 18.49. We'll take 1/2 of our acceleration, which is 0.51. Multiplying 0.51 times 18.49, we get 9.4299. To that, we are going to add 21.93. Now we can do our addition. Our addition is 31.3599. Can we leave our answer in this? No. You've got to take it to 3 significant figures. In taking it to 3 significant figures, we're going to count over and we're going to look at this digit. Since it is 5 or more, it is going to make our answer 31.4. And our unit is in meters. So always remember your answer must be in 3 significant figures. And then box your answer.